What is the principle of separation actually is? In ion chromatography, the interaction between ions in a sample and the charged groups on the stationary phase of an ion exchange column forms the basis of the separation principle. Ions of the opposite charge are drawn to the stationary phase by resin beads that are either positively or negatively charged. The sample ions compete with the liquid mobile phase, eluent, for binding sites on the resin as it passes through the column. Based on their size, charge, and degree of contact with the resin, ions are separated. Ions can separate when stronger interactions force them to elute more slowly, whereas weaker interactions allow them to elute more quickly.
Of the ion chromatography. Ion chromatography system consists of several key components that work together to separate and measure ions in a sample. This diagram shows the schematic of an ion chromatography system. Let's go through the step-by-step of this process together. The general flow path of the ion chromatography starts with eluate, which is the mobile phase, going through a degasser, then going to the pump that pushes eluent flow through the system. Next, go to the injector, guard column, analytical column, and a suppressor. It proceeded to the detector, and the data acquisition system will record data from the detector and show the software chromatograms for analysis. Eluate supplies the chemical solution required for separating ions. Gasser will remove dissolved gases from the eluent to prevent bubble formation. System will delivers the eluent through the system at a controlled flow rate. Sample is injected into the system through a valve injector. Column will protect the analytical column by removing particulates and contaminants. This diagram shows the two-position change format in injector. Column will separates the ionic species based on their interaction with the stationary phase. Suppressor function to reduce the background signal of the mobile phases. Detector measures the ions separated by the column.
Next, I will explain about the application of ion exchange chromatography.
The first one of the applications is water treatment. Ion exchange chromatography is used to remove cations and anions from water that will produce deionized water for industrial and laboratory purposes. Therefore, ion exchangers can soften the water, deionize it, and even be used in desalination. The second one is purification and recovery of pharmaceuticals of antibiotics, vitamins, alkaloids, and hormone, where its ability to provide high selectivity by ion exchange chromatography that can selectively recover antibiotics from complex mixtures, separating them from impurities like proteins and nucleic acids. Next, ion exchange chromatography also can be used in medical purposes, where anion exchange chromatography is used in treatment of ulcers and cation exchange chromatography is used for removing sodium ions and treating hypertension and edema. For example,
high sensitivity, ion chromatography is capable of detecting ions at very low concentrations, making it suitable for trace analysis. Second, rapid analysis. The technique allows for quick separation and quantification of ionic species, saving time in analytical processes. Third, versatility. It can separate a wide range of ionic species, including cations, anions, and organic acids, under varying conditions. Fourth, quantitative accuracy. Ion chromatography provides precise and reproducible quantitative results, crucial for scientific and industrial applications. Fifth, non-destructive analysis. Samples can often be recovered post-analysis for further testing. Sixth, automation and ease of use. Modern systems offer automated operation, reducing human error and enhancing efficiency. Disadvantage. Gradient challenges. Using gradient elution in ion chromatography can be tricky, as it may cause issues like unstable baselines and changes in retention times. Modern techniques like hydroxide eluents help but don't solve all the problems. Next, longer analysis time. Ion chromatography combined with mass spectrometry, ICMS, can take longer to analyze samples compared to other methods like LCMS. This is because special equipment is needed to remove interfering salts before detection. Lastly, detection limitations. Some detection methods in ion chromatography like non-suppressed conductivity detection have lower sensitivity and can be less reliable, making them less preferred unless no better option exists.